Imagine going on a Sunday walk and meeting some neighbors from Venus or Jupiter, or going to Saturn for a summer vacation. Well, this would surely happen if every planet in the solar system would support life. Different creatures from all over the universe would come and visit each other and maybe settle on a different planet than their own. This unimaginable condition could be true if every planet became habitable. But is this even possible? If yes, how? Terraforming or making Venus, our neighboring planet, as habitable as Earth definitely presents possibilities for future human habitation. Despite its current status and inhospitable conditions, Venus shares many similarities with Earth. Both planets have somewhat similar diameters, masses, gravity, and compositions. This also includes central iron core and a rocky mantle. But Venus is still Venus. Its extreme heat, dense carbon dioxide atmosphere, and toxic surface fumes make it vastly different from Earth. To make Venus habitable, two main challenges must be addressed, which are reducing its temperature and altering its atmosphere, that is, the air around it. One method that can be used is using hydrogen bombs to react with the planet's carbon dioxide atmosphere, thereby producing graphite and water, which could potentially cover 80% of Venus's surface with shallow oceans. Whereas to reduce the high radiation dose and the extreme temperature, either a series of small spaceships or a large lens could be used. Another main challenge is Venus's slow rotation. A day on Venus lasts approximately 243 Earth days. But no fear, because massive rotating mirrors could simulate a 24-hour day-night cycle, creating a more Earth-like environment. Phosphine, a colorless, flammable, and pungent gas found on Earth, is highly toxic to oxygen-dependent life forms and has previously been used as a chemical weapon. But this phosphine could point to life in Venus's atmosphere. This gas might be produced by anaerobic bacteria, organisms that thrive without oxygen. Another reason to try to inhabit the planet. Inhabiting Mars has also been an age-old and a popular idea, with some scientists suggesting the use of nuclear bombs to release carbon dioxide and water from its polar caps, which would trigger a greenhouse effect to warm the planet. However, detailed studies show that the amount of carbon dioxide released would be insufficient to create an Earth-like atmosphere, and the risks of nuclear fallout or triggering a nuclear winter pose significant concerns. However, Mars, being a smart planet, gives a solution beneath its surface. Regolith, the planet's surface material, provides radiation shielding equivalent to Earth's atmosphere when layered 5 meters deep. This material could be transformed into cement and be used to build protective domes for any civilization. These domes could be used as a house, living spaces, science facilities, and essential comforts, etc. Not only this, but domed indoor farms could support chickens and crops, with nutrient-rich manure being used as fertilizer. Although the existence of water on Mars has been a hot topic of debate among the scientists, any discovered fresh water could be filtered and utilized for irrigation. Mars's lower gravity would also help conserve water by keeping it near the surface, reducing overall usage. So altogether, we can consider that if habitation is possible in Mars, it would be one of the most amazing discoveries as well as experience even achieved by humans. Now, if we talk about living on Uranus, which is an ice giant, it seems rather unthinkable. Its atmosphere contains hydrogen, helium, and methane. It lacks a solid surface, featuring extremely cold and windy conditions. Still, to make it habitable, the settlements would be airborne, with the use of advanced technologies like near-vacuum ships to maintain buoyancy. Despite the obvious difficulties, Uranus could provide water resources from its icy composition and maybe inspire some innovative solutions for living in extreme environments. But there are some challenges in space which are too difficult to overcome. If we think about the Sun, habitation on it would be like creating ropes from sand. The challenges of building a spacecraft capable of approaching the Sun without melting is too high. Due to a thermal shield made of carbon composite material, the closest any spacecraft has come to the Sun is 8.2 million kilometers, enduring temperatures of 1,377 degrees Celsius. To minimize that, we would need hydrogen bombs, whose transportation would require an even more advanced protection system, adding significantly to the cost and technical complexity. Moreover, the radiation as well as the energy emitted by the Sun is too much to cope up with. A better option would be the destruction of the Sun, which will ultimately disrupt the whole solar system in which we thrive. In contrast to these disputable challenges, constructing cities on the Moon presents a more real but still ambitious vision. Designs like the Shackleton Dome, which were proposed in 2005, visioning a massive 40-kilometer diameter glass dome over the Shackleton crater. While such a structure is viable, smaller interconnected domes made of glass and titanium anchored to the Moon's bedrock would be quicker and cheaper to build. Anorthite, a mineral found on the Moon, could be used to make the glass, while geopolymer concrete made from moon dust and even human urine could serve as additional building materials. There is no doubt that life inside these domes would be totally different from Earth. Moon cities built near the poles would experience only 4 consecutive Earth days of darkness. Diets would primarily be plant-based, with limited options for fish and frozen meat imported from Earth. The Moon's economy would revolve around mining and exporting helium-3, a valuable fuel for fusion reactors. With helium-3 fetching $40,000 per ounce, just 25 tons could power the United States for a year. But this would require international cooperation and understanding. As we can understand that these projects are way ahead of the ongoing ones, so calculating their funds would not be easier. Also, due to treaties, no person could ever own land on the Moon, thereby making places somewhat difficult to live in. Every human works for a place to call home, and such facilities would never exist on other planets. So, although there are means and methods to make some planets in our solar system fit for human existence, the cost and resources required is of too much value to be lost on such a risky job. Still, by allowing ourselves the opportunity to explore and try to terraform these planets, we not only expand our understanding of planetary science, but also offer to ensure humanity's survival beyond Earth. Each experience provides lessons that could address Earth's environmental challenges and pave the way for a multi-planetary future. So what do you think? Should we try to terraform these planets? Because who knows when our Earth decides to retire? Or should we use the knowledge and resources and the funds to do something sustainable on our lovable Earth? Do give us your opinions and suggestions in the comment section. Also, don't forget to come back to the channel to explore more of the unexplored things of the universe.